const keyword in programming is used to declare a constant variable. This means that once a value is assigned to a const variable, it cannot be reassigned. It's important to understand that const does not mean the value is immutable, especially when dealing with objects or arrays. It simply means the variable identifier cannot be reassigned to a different memory location. The provided code allows the declaration of both let and const variables. The let keyword declares a block-scoped local variable, optionally initializing it to a value. Unlike var, variables declared with let have block scope, meaning they are only accessible within the block of code where they are defined. Const also declares a block-scoped local variable, but with the added restriction that its value cannot be reassigned after it has been initialized. When you declare a variable with const, you must initialize it at the same time. For example, const my variable equals 10 is valid, but const my variable is not and will result in an error. After the variable is assigned a value, any attempt to reassign it will also result in an error. It is important to note that the const declaration creates an immutable binding, not an immutable value. That is, the object to which the variable refers is still mutable. Consider the following example: const my object equals property 11, property 22. You cannot reassign my object to a new object, like my object equals property 33. This will throw an error because you are trying to reassign the constant variable. However, you can modify the properties of the existing object, like my object. Property 1 equals 3. This is perfectly valid because you are not reassigning the variable my object, but rather modifying the object it refers to. The same principle applies to arrays. You cannot reassign a const array to a new array, but you can modify the contents of the array. For example, const my array equals 1, 2, 3. You cannot do my array equals 4, 5, 6. However, you can modify the array like this: my array pusher, or my array 0 equals 5. Understanding this distinction between immutable binding and immutable value is crucial for using const effectively. In many programming languages, including JavaScript, the const keyword is block-scoped. This means that the variable is only accessible within the block of code in which it is defined. A block is typically defined by curly braces. For example, if you declare a const variable inside an if statement, it will only be accessible within that if statement. The let keyword also has block scope. Both let and const were introduced to address some of the issues with the var keyword, which has function scope. Variables declared with var are accessible throughout the entire function regardless of where they are defined. This can sometimes lead to unexpected behavior and bugs. Using let and const helps to create more predictable and maintainable code by limiting the scope of variables. When deciding whether to use let or const, it is generally recommended to use const by default, unless you know that the variable will need to be reassigned. This helps to prevent accidental reassignment and makes the code easier to reason about. If you do need to reassign the variable, then use let. It's important to note that using const doesn't make your code run faster or more efficiently. It's primarily a tool for improving code clarity and preventing errors. In some cases, compilers or interpreters may be able to optimize code that uses const more effectively, but this is not the primary reason for using it. The main benefit of const is that it helps to enforce immutability, which can make your code more robust and easier to understand. One common use case for const is when declaring variables that represent configuration settings or other values that should not change during the execution of the program. For example, you might use const to define the API endpoint for a web service, or the maximum number of items that can be stored in a cache. By using const, you can ensure that these values are not accidentally modified, which could lead to unexpected behavior. Another important aspect of using const is that it can help to improve collaboration among developers. When multiple developers are working on the same codebase, it's important to have clear conventions for how variables are declared and used. By using const consistently, you can make it easier for other developers to understand your code and avoid introducing bugs. Furthermore, many linting tools can be configured to enforce the use of const whenever possible. These tools can automatically detect variables that are not reassigned and suggest that they be declared with const instead of let. This can help to ensure that your code base adheres to best practices and that const is used consistently throughout the project. In summary, the const keyword is a powerful tool for declaring constant variables in programming languages. It helps to prevent accidental reassignment, improves code clarity, and can make your code more robust and easier to understand. While the provided code does not disallow the usage of const, it is important to understand how const works and how to use it effectively. Remember that const creates an immutable binding, not an immutable value, and that it is generally recommended to use const by default unless you know that the variable will need to be reassigned. The use of const and letover var promotes better coding practices by enforcing block scope and minimizing the risk of unintended variable mutations. Block scope limits the visibility of variables to the block they are defined in, which reduces the likelihood of naming conflicts and makes code easier to reason about. By contrast, var has function scope, which means that a variable declared with var is visible throughout the entire function, regardless of where it is declared. This can lead to unexpected behavior, especially in large and complex functions. The use of const also encourages developers to think more carefully about the mutability of their data. By default, data should be immutable unless there is a clear reason to make it mutable. This helps to prevent accidental modification of data, which can lead to bugs that are difficult to track down. Furthermore, immutable data is easier to reason about and test, which can improve the overall quality of the code. In many modern programming languages, there are also other ways to enforce immutability, such as using immutable data structures or libraries. These tools can help to make your code even more robust and prevent accidental data modification. When working with objects and arrays, it's important to remember that const only prevents reassignment of the variable itself, not modification of the underlying object or array. If you want to prevent modification of the object or array, you will need to use other techniques, such as freezing the object or array using object freeze or using immutable data structures. Object freeze is a method that prevents adding, removing, or modifying properties of an object. It makes the object effectively immutable. However, it's important to note that object freeze only provides shallow immutability. If the object contains nested objects or arrays, those nested objects or arrays can still be modified. If you want to achieve deep immutability, you will need to recursively freeze all nested objects and arrays. Another option for achieving immutability is to use immutable data structures. Immutable data structures are data structures that cannot be modified after they are created. Instead of modifying the existing data structure, any operation that would normally modify the data structure returns a new data structure with the changes applied. This ensures that the original data structure remains unchanged. There are many different immutable data structure libraries available for various programming languages. These libraries typically provide immutable versions of common data structures, such as lists, maps, and sets. When working with concurrent code, immutability is especially important. Immutable data structures are inherently thread-safe, because they cannot be modified by multiple threads at the same time. This eliminates the need for locks and other synchronization mechanisms, which can improve the performance and scalability of concurrent code. In summary, the const keyword is a valuable tool for improving code clarity, preventing errors, and promoting immutability. While it doesn't provide complete immutability, it's a good starting point for writing more robust and maintainable code. Remember to use const by default, unless you have a clear reason to use let, and to consider using other techniques such as object freeze or immutable data structures when you need to ensure complete immutability.